Welcome to this week's video. Today we're going to be looking into object detection with Python. I'm by no means an expert in AI, machine learning, but I just wanted to learn how to build cool stuff using all these new AI models out there. So I've done some research and I saw we can actually find some objects in an image by using Python and using some models that are already pre-trained. So if you're an engineer, just want to build stuff but not necessarily know how the inner workings of those models work, then maybe here this video is for you. So bear with me and let's see how we can use Python and machine learning to actually detect some objects in an image. So I have here my virtual machine open. I have a version of Ubuntu, mate Ubuntu running. I'm going to create here a new folder called image detector. And that's going to be the folder that's going to be the base for everything. So let's open here VS Code. I just opened the terminal here. And then my VS Code window should pop up here. And then I simply open the folder that I just created. So I click here on open folder, go to desktop where my folder was in image detector. So I open that and that's a clean slate for us to start our project. I'll click here on trust the authors. I'll close the welcome window. And the first thing I'll do here is to just create a main.py file. That's gonna be where all the code for this project is gonna be written. And I realize here I don't have the Python extensions for VS Code, so if you need that, go ahead and install. That might be useful for you. All right, once the Python extensions are installed in your VS Code, the next thing to do is to start a virtual environment so that all of the libraries are contained in that environment. So you go ahead and run this command over here, python 3 -m vend, followed by the name of the virtual environment you want to create. In this case, I did .vend, so it's a hidden folder called .vend. And to activate the environment, you're gonna do source.vend bin activate. And now you're in your virtual environment. You can install Python libraries here, and they're all gonna be installed in this folder only, so you don't mess up with your system-wide Python. All right, for this project here, we're gonna be needing a few libraries. We're gonna be needing CV2, which is OpenCV for Python. We're going to be needing the JSON library, so let's import that over here. We're also going to be needing the NumPy library, so let's import NumPy, and also we need Tensor Flow, so let's import Tensor Flow. These are all libraries that are required for you to run these AI models to detect objects in an image. You can notice here that they are marked as with this yellow underline thing. It means that the interpreter of Python is not recognizing them. That is because we haven't installed them yet. So we can go ahead here in the terminal and install the missing libraries. So the first thing you can do here is to install Python OpenCV. We're gonna run that command and wait for us to download all the files and then install them in our virtual environment. After Python OpenCV is installed, we can then go ahead and install TensorFlow. So we're gonna head and go pip3 install, followed by TensorFlow. And now it's going to download everything. It might take a while, so just wait here until it installs. And that should also install NumPy when you install TensorFlow. If you want to check all of the libraries in your virtual environment, you can simply run pip3 list, and then you can see all the installed Python libraries here. And you can check that TensorFlow, NumPy, and OpenCV Python are all installed. With those libraries, then we are ready to actually start coding our object detection project over here. Okay, so I just opened the browser. I googled for TensorFlow object detection, and first link here goes to this page by TensorFlow Hub. We see here object detection, and we can just like read a bit of the tutorials. They give you a few applications here, but the important thing for me here was to check a certain model name, which is described at the top of that website. That model is this faster RCNN Inception ResNet version 2. We can go here to Kaggle and you can see here a summary of this model, what it does, and all the information you need to actually run it. You see here, it's a model trained on the Cocoa label set. So it can provide you several objects that are defined in the Cocoa label set. You see here, it takes a specific input, and here are the outputs by the model. So you can get the detection classes, the bounding boxes that you can use to actually overlay on the image for you to actually get the detections and the scores, along with other metadata you might want. So you can go ahead and click here, download. You can download the model as a tar.gz file. That's a compressed file. We're just gonna wait for that to download, and then once that is done, we can extract the zip file and just copy it over here in our folder where our VS Code is open. And you see here we have the folder, and along with the path to that folder where we just put it in our VS Code here. And we see here this .pb model. That's actually the file that's going to contain all of the weights, the pre-trained weights of your model that TensorFlow can then use to detect objects in your image. As I mentioned, this model is going to be using the COCO dataset. That's a large-scale object detection dataset that uses a bunch of images, a bunch of labeled images, and then you can output from that a few labels. I think there are around 90 something labels that you can detect with this COCO label dataset. And for example, here you see a bunch of examples. You have your microwave, a mouse, laptop, TV, all sorts of things you can detect with this model. In our case, we're going to be using a picture of a kitchen later, so you can actually detect what's in that kitchen. And I found this other website here where this guy simply put all of the labels in this nice JSON format. So I'm going to go ahead, copy that, because that might be easier for us to work with, because we can simply read this JSON format and then we can have a better time just mapping each ID to the current label. Here in VS Code, we have the path to our model that we just downloaded is this folder. So we just put the path of the folder, and here we're going to be using this model, and this model variable is going to be containing the actual path that we're going to be loading with TensorFlow. So we simply do that by running tf.saveModel.load and giving the path as an input. Next step here, we want to open the COCO labels JSON file that we just copied. So we're going to go ahead and use a with open COCO labels.json as f. That's going to be our file, and we're going to be opening that as a read only. And then we're going to assign the contents of our file to this variable called labels. We do a json.loads followed by our file, and labels should now contain all the contents of our JSON file. We also have a image that we downloaded for testing. It's called kitchen.jpg, and we're now going to be simply assigning a variable to that name so we can reference later. We're now going to be loading that image by running this command here. So we're going to be assigning the image variable to tf.io.read file, followed by the image path. That's going to be loading our image. Then we're going to be typing tf.image.decode JPEG. And that's going to get our image and decode it so that it has the right color channels for us. In our case, we need 3 channels for RGB, because that's what the documentation said in Kaggle here in the model. It says that it needs 3 channels for the colors RGB, and those channels should be each color in a range from 0 to 255. Those are the ranges that it needs to take. This model also says here that it can take a variable size image, and then it's going to be resizing it to 640 by 640. They also have I think a 1024 by 1024 model, which allows you to use larger images. If you have very fine details in your image, you can use that, and it might be able to detect those small objects better. But of course, it takes also longer to run. So here I have the image where I decoded to JPEG. I assure that it has 3 channels for the colors, and each channel has this uint8, which means 256 values for the color. So from 0 to 256 for each color channel. And finally, we have this expand dimensions. We need there to add a new dimensions, because according to the model, we need a input of size 4, where the first input is just simply a dummy dimension. So we're gonna add a new dimension here by putting x is equals to 0. We finally run here the inference model by simply running model and providing the image as an input. And we're gonna be assigning the results to this detections variable. The detections variable is a dictionary, and we can then retrieve a few of the elements from that dictionary. For example, the detection scores, we can retrieve it. simply by doing detections and then square brackets detection scores. We're going to be taking here the first element of that list and then convert it to a NumPy array. We do the same thing for the classes and also for the bounding boxes. You can see here the outputs of the model. It says it gives you the number of detections, the detection boxes, the classes, the scores. So you can get all the information you want from this Kaggle page here. And we're simply just retrieving the stuff that the model can give us, right? And that's all available in this dictionary called detections. We're just getting the specific fields of the dictionary here, like the scores, the classes, and the boxes. To actually display the image later so we can see all the bounding boxes nicely, we actually need to convert our image back to a format that we can actually see it. So let's go ahead here and convert it to a NumPy format again. And there was a detail here where the colors didn't really match. So we might need to convert the colors from the original image to another format. I think because one of the formats they use RGB, but we might need to convert it to BGR, right? So just so we can have the same colors of the original image. So we're gonna have this step here just to convert the colors back to the original ones. There was a small detail here where with the JSON files that we downloaded with the Cocoa dictionaries, it wasn't as easy to read. And so here I'm simply defining a new dictionary called Cocoa labels. We're just gonna be going over every single line of our original JSON file and just mapping each ID to the specific name. So now we have an even simpler dictionary to work with, which simply has an integer for the ID mapped to the label name. So for example, if Apple, I don't know, if it's ID 52, we're just gonna have a dictionary mapping 52 to the word Apple. Now that we have all of our variables that we need, like the scores, the classes, and the boxes, let's go ahead and loop over all of our scores, because then we can see which scores are high enough for us to make a prediction. So we're gonna be running a loop over all of the detection scores that we have here. And we're gonna see if the detection score is greater than 0.5. So if the model is more than 50% sure that that is a given label, then we're gonna actually try to draw those boxes on our image. First of all, here we're gonna get the height and the width of our image. And because here we have 4 dimensions, we only care about the H and the W, which are the height and the width. We need to put those dummy variables there, underscore, underscore, and underscore. We're only really caring about the middle two. So that's why we need here H and W. And we set that equals to image.shape. And then here we're gonna get all of the corners of our detection boxes. That's gonna be Ymin, Ymax, Xmin, and Xmax. That's gonna be defined by the detection boxes variable that we just retrieved. And then here we can reassign those edges and make them sure that they are, they're corresponding to the original shape of the image. So we might need to scale them up or down. Xmin and Ymin, for example, they're simply a number between 0 and 1. They're just a proportion of the original image. So we just need to scale that up so that we can get the actual pixel values that we want to draw the boxes. Now here we can actually draw the rectangles on our image. So we're going to be using cv2.rectangle. We first pass our image, followed by the 2 corners of our boxes. So there's going to be the lower left corner followed by the upper left corner. So that's why we're giving here 2 tuples for xmin, ymin, and then xmax, ymax. And then the color of a rectangle. Here I think we're giving a green rectangle and the thickness of the line that we want the rectangle. And here we want to put a text, just the label of the rectangle that we just discovered. So we're going to be doing here cv2.putText. And then we're going to be passing the image and also getting here the labels, right? So that's when we're going to be using our dictionary from the Cocoa labels JSON file that we get. We're going to simply be getting the detection class that corresponds right to the name, and that mapping is done by the labels dictionary that we got. And then we give the position that we want that text to be in, followed by the font, and then also followed by the size of the text that we want to write. And here we also need to pass the color that we want the text to be in and the size as well. Now we can actually finally show the results on our image. So we're going to be calling here cv2 image show, and we're simply going to give it a name. That's going to be the name of the window that's going to be showing our image. And we're going to finally be passing the image after we put all the rectangles for each detection. Then we're going to just simply show that image and wait until the user presses the key so we can close it. And finally, we just destroy all of the windows after the user closes the specific image. Now everything is done, we can simply run python 3 main.py and wait for our script to run. This might take a long time depending on which hardware you have. In my case here, I'm running a virtual machine, so that took even longer. But let's just wait and see what happens. One other detail here is that I added a new line called image write. So in addition to showing that on the window, we can actually write the files to our current folder so we can open it later as well. So we save the information. We also see here we get some warnings here saying that we're exceeding our system memory. I think in this virtual machine I didn't put enough virtual memory, so that's why it's doing that. But here you can see this image is very large. I think I chose a very large image that I cannot even show properly. But anyways, the important thing here is that I also saved it as this output.jpg. So just open that so we can see all of our labels. So you see here, it actually detected a lot of stuff. Detected the vases, for example, oranges, different bowls, also detected the oven, potted plants, and even the microwave, right? So we get all these labels here that were automatically labeled for us with the bounding boxes. It's interesting too how the bounding boxes, they can overlap with no problem. And again, all these labels, they were present in the Cocoa labels. So as long as what you're trying to detect is present in the Cocoa labels, it means that the model was trained to detect that specific object so you can use it. But that's pretty much all that I have for today's video. I just wanted to show you how you can actually use Python to detect objects. Maybe you have a nice project in mind that you can use this algorithm to detect some things. As long as it's in the Cocoa label set, you should be fine. But I'm actually interested in seeing, can I actually run this model on a Raspberry Pi? Maybe that's for a new video, but for this one, I just wanted to show you how you can actually use that for your own projects. So thanks for watching, and I see you next time.